Okay, so I wrote a few things down that we already had. We already have the MacLaurin series that you solved correctly. We also have all of the derivatives of the natural log of 3x plus 2, which I wrote out. And I did that all the way up to the 4th degree because to find the remainder, let's remember what the remainder is. Here's the equation for the remainder. Remainder at n of x is equal to f at the derivative of n plus 1 of z x minus c n plus 1 all over, sorry, that's not correct. Only the actual functions of it. All over n plus 1 factorial. So we have to ask ourselves, what do we know? And the question is, do we know n? Yes, n equals 3. The problem told us that. So we're trying to find the remainder at degree 3. Okay, that's good. So n equals 3. What does x equal? And what does c equal? This is the real c, not some fake c that we're going to use later. X and c are actually equal to, x minus c are equal to this right here, the repeated factor here. So, what is x minus c? X minus c is x. If we do some math, we can figure out very easily that if x minus c is equal to x, c must be equal to 0 and x must be equal to x. Does this make sense? Can you see it on the paper? Now you can. Yes, it makes perfect sense. Because it's this right here is x minus c. And if x minus c equals x, then c equals 0 and x equals x. Okay, so now let's fill in what we know from our problem up here. So, the remainder at 3 of x is equal to f of the f derivative at n plus 1, so the 4th derivative, negative 486 over 3x plus 2 to the 4th power times x, which is x, minus c, which is 0, to the 4th power, n plus 1, 3, all over n plus 1 factorial, 3 plus 1 factorial, or 4. So, where does the c come in? Well, it's actually z. So this should actually be a z right here because it's f derivative of the n plus 1 to the z. So this is z, and that's x. Okay, so let's reduce that. So we get r to the 3rd degree of x equals negative 486 over 3z plus 2 to the 4th, x to the 4th, over the 3 plus 1 factorial is equal to 4 factorial, which is equal to 24. If you don't know why, do your math. 4 times 3 times 2 is 24. So we get 24. Great. We can flip and multiply this. And what we will get is, let's reduce it further. negative 486 x to the fourth over 3z plus 2 to the fourth times 1 over 24. These reduce. If you divide this and this by 6, you get negative 81 x to the fourth over 3z plus 2 to the fourth power, and then you need a 4 from here because you divide both by 6, so you get a 4 here, and that's our answer. And where did we get C? Well, we just replaced the z with a different value. 3c plus 2 to the fourth. So we took the c that's supposed to live over here in standard notation, and we replaced it with that c. And those are not the same c's. And yes, it pisses me off.